Hey AP Calculus, I hope you found the videos on Khan Academy to be helpful in regards to L'Hopital's rule. Sal Khan is a great man, he makes everything very great. So L'Hopital's rule in short is used to evaluate a limit of indeterminate form, for example 0 over 0 or an infinity over infinity case, and it's gonna be very helpful for us to evaluate those tough limits. Before we get started, I just want you to understand that L'Hopital's rule used to be a BC Calculus topic. So as you search for resources online, if you find some from BC Calc exams, don't get nervous, because that's where they all used to be. So definitely, fair game for AP Calc this year, or AB rather, this year. Let's look at the first problem. It's a no-calc problem, limit as x approaches pi of this guy. And the first thing you want to do, every limit problem is the same. The goal is direct substitution. So if you plug pi in here, you get cosine of pi plus sine of 2 pi plus 1, all divided by, it's going to be pi squared minus pi squared. In the numerator, you're going to get cosine of pi, which is minus 1, plus sine 2 pi 0, plus 1, all divided by 0. Does give you 0 over 0. So that's an indeterminate form, which means L'Hopital's rule applies. What you want to do is take the derivative of the numerator and the derivative of the denominator. So we're going to do the limit as x approaches pi. The derivative of the numerator, derivative cosine, is just a negative sine x plus derivative of sine 2x is going to be 2 cosine 2x. Derivative 1 is 0. All divided by x squared, the derivative of x squared is 2x, and the derivative of minus pi squared is just 0. So now that we have this piece right here, what you want to do is plug the pi back into the problem, okay? So if you plug pi back into the problem now, you're going to get negative sine of pi plus 2 cosine of 2 pi, all divide 2 times pi. And this is going to give you an answer. We'll just actually, scooch it down a little bit. This is, oh my, it was too much erased there. Let's try to just go, there you go, go right back here. We'll just try that again. That's better. Okay. What happened? Oh no. What have I done? Oh, okay. Wow. That was terrifying. Let's try this again. Little bit. Oh my goodness. All right, you know what? That equal sign is totally fine. It's not hurting anyone at all. It's okay. Let's evaluate. So you get negative sine of pi, which is 0, plus 2 times cosine 2 pi, that would just be 2 times 1, all divided by 2 pi, gives you a final answer, the 2's cancel, of 1 over pi. 1 over pi would be the answer to this problem, which I believe was choice B. Choice B. Okay, so that's one example of L'Hopital's rule in action. Let's take a look at the second example. It's a free response question. No calc is allowed on this exam. And we're going to jump down to question question C. So let's read the problem first, just so we get an idea of what's going down. This is F, okay? This is F. Graph here shown is F, and it says the graph F has horizontal tangents at -1, 1, and 2, and G is the antiderivative of F. Very important fact. So G is the antiderivative of F. So essentially, if we think about G as the original, F is the derivative. The graph that we are looking at is the derivative of the original function in this problem. Okay? Well, here we go. Part C asks to find the value of the limit as x approaches 0 of g of 0 plus 1 over 2x. So the first thing you want to do is go ahead and try direct substitution. So if we just take a look at this limit, it's the limit as x approaches 0 of g of 0 plus 1 over 2, you know what, I'll just put x's in for now, and we'll do the 0 in just a second. So we'll just do a 0 here, okay? There we go. So let's see if we can figure this out. Now, obviously, this is just going to equal, I wrote it, I just realized I wrote an x in there as well. Sorry about that. 0 rather, instead of writing x. This is going to be g of 0 plus 1 over 2 times 0, which of course is 0 plus 1. We just don't know what g of 0 is. G of 0 is actually, going to be a little bit more challenging. We have to use the fundamental theorem of calculus to find it. So what we know is the initial condition provided was g, oh, that was not a great circle, was g of 3 is equal to 7. And so that is the x value of the initial condition is 3. The y value of the initial condition is 7. Okay? So if I were to build the function g of x, it would equal the y value of the initial condition, 7, plus the, I'll just write up here just so you don't have to go back up. This was the initial condition, plus the integral from the x value of the initial condition to the variable that I'd like. So let's do x. And this is f prime of s ds. Or actually, you could just call it f, seeing as how they called f to be that piece. So we'll just call it f. I'll call it f. Or I could do g prime of s as well if I wanted to. It doesn't really matter. So let's get an answer here. What I want is g of 0. Okay, so that'd be 7 plus the integral from 3 to 0 of f of s ds. And that's going to be 7 minus the integral from 0 to 3 of f of s ds, because of course I have to flip the bounds of the integral. And then if you use the figure here, what we're trying to do is calculate the area here, and the problem is going to give it to us. It's going to give you a 5 and 3, so we want these right here. So we want 5 and 3. We're integrating from 0 to 3. So they say that's going to be 5 right here and 3 right there. So we know that the integral of 0 to 3 is 8. So we'll go plug that in. So this is equal to 7 minus 5 plus 3, or equal to -1. Okay, so that was just the fundamental theorem of calculus. Great review for the AP exam coming up. And I use that right up here. Just use that -1 right there. And what that does is it allows me to prove that I have a limit of indeterminate form. I have the limit is equal to 0 over 0. So I can't do anything. I have to use L'Hopital's rule. So if I L'Hopital rule the problem, the derivative of the numerator is just g prime. The derivative of the denominator is just 2. So the problem becomes, after I L'Hopital it, it's going to be the limit as x approaches 0 of g prime x over 2. And the nice thing about this problem is g prime is just f. Excuse me, it's just f. So this is really asking what's the limit as x approaches 0 of f of x over 2. And this can be solved because f of x is the graph right here. The limit as you approach from the left and the right is 0. So it's equal to 0 over 2 or 0. So that's just a couple of L'Hopital practice problems to complete our curriculum. Try some more on Khan Academy or straight from the textbook, excuse me again, to really solidify that. All right? Great.